This is the video for section 3.4 notes, slides 14 through 16. All right, so in slide number 14, we are trying to find the derivative rule for b to the x, where b is some constant. So it's very similar to e to the x, but e is a specific constant, approximately 2.718, but b is some other constant, like 2 or 3 or 5 or 10 or whatever. So if I have something like 2 to the x, how do I find the derivative of that? So we're going to use this rule that we're going to develop right now. All right. So first of all, just like we've done a number of times, we're going to let y equal b to the x. So I'm really trying to find dy dx. All right. So if y is b to the x, what we want to do is we want to use kind of the inverse property that we used just like when we did the inverse trig functions in section 3.1. So I'm going to rewrite this using the definition of logarithms. So if y equals b to the x, then I can say that the log base b of y is equal to x. All right. And so now we're going to use what we already know from section 3.3 to find this derivative rule. But in order to do that, all right, I have the log base b of y. And we don't know how to deal with log base b. The only thing we know how to deal with is the natural log. So I'm going to rewrite the log base b of y. So on the side here, the log base b of y may be rewritten as the natural log of y divided by the natural log of b. This is a property of logarithms that you should be familiar with, that we will discuss a little bit more in a few minutes. But anyway, I can rewrite the left side of this equation as the natural log of y divided by the natural log of b, and then equals x. All right, now, once we are here, we are going to take the derivative of both sides. But uh, some people would look at the left side and think we need to use the quotient rule. We actually do not need to use the quotient rule. Okay, I'm going to rewrite the left side as 1 over the natural log of b times the natural log of y equals x. All right, now 1 over the natural log of b. Well, what we have to remember is that b is a constant. So the natural log of b is a constant. And so 1 over the natural log of b, that whole thing is a constant. And if that is true, then when we take the derivative with respect to x of the left side, then what are we going to end up with? Well, we're going to end up with 1 over the natural log of b times the derivative of the natural log of y. What is the derivative of the natural log of y? It's 1 over y times dy dx. Remember, we're taking the derivative with respect to x. Equals. Now, on the right side, dx is just 1. All right, so now, what did I want to find? So going back to the original, we wanted to find dy dx. So I have to solve for dy dx. All right, so if I solve for dy dx, I would be multiplying by y. So I have 1 on the right side, so I multiply by y, and I multiply by the natural log of b. So y times the natural log of b. But what was y? Y was b to the x. And so dy dx is going to be b to the x times the natural log of b. And so what is the derivative with respect to x of b to the x? It's b to the x times the natural log of b. Okay, so then what is the derivative with respect to x of b to the u? Well, you should already know this answer. It's b to the u times the natural log of b once again, but then apply the chain rule times du dx. So of course, the one on the right here is our memorization quiz rule. All right, so that's slide 14, so make sure you have the rules written correctly. All right, moving on then. Slide 15. Now, how do I find the derivative of log base b of x? Well, it's actually pretty simple. All right, we actually just kind of figured it out, but I will reiterate. Let's say that y is the log base b of x. So what I would actually do is I would just rewrite this. The log base b of x is actually the log, the natural log of x divided by the natural log of b. And so I don't need to switch it around at all. I'm just going to take the derivative. So what is dy dx? Well, once again, remember, we can rewrite this as 1 over the natural log of b times the natural log of x, and therefore the derivative would be 1 over the natural log of b, remember that's a constant, times the derivative of the natural log of x, which is 1 over x. And so, okay, we actually are going to rewrite this as 1 over x natural log of b. And so the derivative of the log base b of x is 1 over x times the natural log of b, which means that the derivative with respect to x of the log base b of u is 1 over u natural log of b times du dx. Remember, don't forget to apply the chain rule. All right, so that is slide number 15. So once again, you want to make sure that you have your derivative rule with the chain rule written correctly, and then you are working on having that memorized. All right, moving on to slide number 16. All right, so slide number 16 is just a review of some things from pre-calc. So we should recall, number one, if the log base b of x equals y, then b to the y equals x, right? This is just the definition of logarithms. All right. Number two, if I have the natural log of a times b, then we can rewrite that as the natural log of a plus the natural log of b. In the same way, if I have the natural log of a divided by b, then we have the natural log of a minus the natural log of b. All right. Number four, I actually referred to this earlier. The natural log of a to the c power is c times the natural log of a. Now, it's important to note that if I have the natural log of a to the c power like this, that does not equal c times the natural log of a. So make sure that you are aware of that. All right. But then number five, if I have the log base m of p, that would be the natural log of p divided by the natural log of m, or the log of p divided by the log of m. Remember, when I don't write a base there, that would imply that it is base 10. All right. And then 6 and 7 are based on the inverse properties of exponentials and logarithms. So b to the log base b of x, well, b to the log base b are inverses, and so those would actually just like cancel each other out or undo each other, and so we end up with just x. Or the log base b of b to the x is actually also just x, because those things kind of like cancel each other out as well. All right, so those are some properties of logarithms that you should be familiar with. Remember, those are just a review from pre-calc. All right, so that is slides 14 through 16.